What is data modeling? Why data model? And what is cardinality? Different types of cardinality, like a one-to-many relationship. The types of relationship, we'll take a look at it, and also we'll continue with what is many-to-many relationship. How do we overcome that? If time permits, list of the topics we'll cover it. Okay, so now what is a data model? Data model is compared with the roadmap or the architect's blueprint. Before you construct a house, make sure that you have a proper blueprint in place. Without the blueprint, no one construct the house because they cannot afford the making changes to the house once it has been constructed. Okay, so if it is a minor change or minor provision required, then it is fine. If it requires, sometimes what will happen, you need to have a tap in your kitchen. Somehow you did not consider that as part of your blueprint. First of all, you did not have blueprint. So in that case, what will happen is you will end up drilling from the top floor to till your floor. You need to drill everything. You need to do everything. It will cause a lot of, it leads to a lot of time and money, right? And effort also. So like how we have a solid blueprint in place before we construct the house, similarly, before you build any applications, mobile application or web application, you develop any application, make sure that you have a data model, solid data model design in place. And when it comes to Power BI, yes, you have to do data model design. Otherwise, what will happen is you cannot do slicing and dicing. You cannot slice and dice your measure with various dimensions. Okay, so as part of the data model, what we do, we define the relationship. Okay, for example, customers orders product and the products falls under different categories. This is a simple example. Here, each entity, these are the entities or nothing but the tables. These tables, how it interacts with other tables. Okay, how it relates with the data in other table. Okay, who orders the, let's say you have a just orders table, but you have the order number, order date, everything is there. Order related detail, including the customer key is available. But at any point in time, if somebody asks you, so can you tell me the customer who raises this order? Then you need to have a customer table in place in order to give the customer name for that specific orders. Similarly, okay, what is the product name? Can you tell me the product? Because in this table, you will have only the key columns from other lookup tables. These are kind of your lookup tables. Which one? The customers, products and regions, the categories. These are kind of a lookup tables. Okay, so hence you need to do a lookup in these tables to get the descriptive information for each facts that are there in your order, each order. Okay, you will have the product ID here, but you will not have the product name. You don't store the product name here because of the to avoid the redundancy. We don't store the product name in orders table, and also we don't store the customer name here. Instead, we store the customer name and along with the customer ID in customer table. Similarly, we store the product name along with the product ID in the products table. But what we do is, if I wanted to know if I want to know which products and which customers raised an order, if you want to know that the customer name and product name, you pass the order per customer ID from orders table to your customer table to get the customer name. You just pass this the customer ID to this customer's table. This customer's table have customer ID and customer name. So for the corresponding customer ID, it will return the customer name. Basically, we want the data from these three tables. So in that case, you need to create the relationship between the tables. See, these table are having one-to-many relationship or many-to-many relationship. Okay, before we dive in, understanding what is one-to-many, many-to-one, let us understand this one, the types of data model. The one is the conceptual data model. Other one is the first one is the conceptual. Next one is logical and physical. First, we'll start with we conceptualize as part of the requirement stage, right? At the end of the requirement stage, we conceptualize what are the entities that are required. Okay. For example, in this case, these are the tables that are required. While discussing with the key stakeholders or the managers within the company, what you do is you understand, okay, they need the sales table should be there. It should be the granularity should be day level. The granularity of this table should be day level. That means you need to capture day-to-day transactions also as part of the sales table for your analytics. Okay, and product table is required, story is required, time is required, even customer table is required. Okay, in order to do a lookup to get the customer name. So first you will get an idea about what are the entities that are required, and you will have an high level understanding of the data flow. Okay, how the data flows and what are the relationship between the tables as what are the conceptual data model while interacting with various stakeholders in your with the customer. Okay. Next step, what you do is once you are done with the conceptual data model design, you share it with the stakeholders and ask them to review it. In case any changes required here, anything needs to be included, you amend it and again you send it for the sign off. Once they sign off, the next step is we'll jump into the logical data modeling part. And here what we do is we go one step further and we go and identify all the attributes that are required as part of these tables. You will be identifying it, and also you will define the relationship, the cardinality for these tables. You will define, is this a one-to-many or many-to-one or many-to-many relationship, or one-to-many, sorry, many-to-one, one-to-many. Okay, that thing you will design it here. The next step is you jump into the physical data model. In this case, what we do is we will define the data type for each column and then the width of the columns. And then what we do is we will again go back and share it or liaise with, or we will socialize the design document with the respective team, the stakeholders team. Once they approve it, what we do is we will go ahead and physicalize the table. The conceptual and logical model, what is the difference? Conceptual will understand only the tables. What are the tables that are required? Whereas here, each table, what are the columns that are required? Okay, understood? And also we'll get, we'll define the relationship between the tables. Okay, so one to many, many to one, something like that. Okay, and then finally, we'll identify the data types. We define the data types for each columns and the width of the each column. We will define it and then we will physicalize it. Physicalize in the sense we will create the table in your database. This is how your physical data modeling look like. Look here, in this case, we define the data type here, right? So, but in this case, you just define the column names, whereas here you just, empty tables. Okay, you just get a high level big picture. So what are the tables that are required? And the next step is each table, what are the columns required? What are the relation that needs to be defined? And finally, we define the data types. We go one step further, right? So we extend the logical data modeling by defining the data types for each columns and the width for the same thing here. Okay. Listen, now your data model is ready. You created your tables, everything in a subject area, some, some schemas. Fine. So now the question is, first of all, why should I do data model in Power BI? Okay, to answer to this question, if they have already done it, for example, you have a SQL server, wherein in your customer, they already have a SQL server. So they already deployed a data warehouse there. Okay, they created a data warehouse there. They did all the data model design, everything. Then we don't have to do anything from our side. In the case of new project, fresh project, you have to do everything from the beginning. Okay, you have to understand the requirements, capture the requirements, and then what you do is the next one, detailed requirements, and then what you do is conceptual design, more data model, all the things you need to do it, and then they need to physicalize the table from the scratch. In the new project, if the already existing, the data warehouse is already there, or the OLTP tables are already there, they already did the normalization, denormalization, then you don't have to do anything. Simply you can import the tables. But even after importing the tables, make sure that in Power BI, the relationships are defined correctly. Okay. So if the relationships were not created, if they don't have any data warehouse already in place, you need to do the data model design. Even if the data model design is already in place, you need to validate, okay, whether the required tables got imported or not. So are the relationships are correct correctly defined or not. You need to check it. Okay, and again, you need to come up with some kind of workaround in case of more than one relationship required between the tables. How we are going to deal with that when it comes to Power BI. I will start with one simple example. Why data model is required. The data model design is required in Power BI. So what I will do is I will just go here, and this is my Power BI desktop. I just go here and then I'll import a couple of files here. So this is my table. Look here, all the columns that are required. Okay, fine. I just go ahead and load it. This is my fact table. And the next one is home ribbon, and then get data here. Here, what to do is dim location. This is the normal thing. The column names were not correctly mentioned. We just promoted the row header as a column header. The first row as a column. Here I just say dim location. We'll give some meaningful name. Dim underscore location is a dimension, location dimension table. And if I go to the model view, this is your model view. You can see that the relationship has been created automatically. This line is nothing but the relationship. Okay. And if you keep the cursor on top of this, if you hover the cursor, you can see that in both the tables, the location key got highlighted, which means these two tables got created based on the common column between these two tables. In this case, it is a common column is location key. Okay, I'm done with it. I just go to the report canvas. I just select something like table visual. The table visual, what I do is I just go here and drop the location name from my location table. And then in the sales fact table, what I do is I just go here and drop the sales amount out here. It's good. Okay. And for example, I just show you here one thing. I remove the location name. If I remove the location name and if I drop only the sales amount column here, from here to here, right? I just drop it, but I can see only one value here. I can see only one value. Did I do any sum? Nothing, right? Simply I drop the sales amount column in this visual and it gives me the total sales here. I did not do any sum anything, but the reason is why it gives the total sales value that by default, all the numeric columns, for example, the profit, quantity, sales amount, And cost rate, these are the number data type. These columns are having number, maybe it's a whole number or decimal, it's a number type. For the number type in Power BI, what it does is, right, if you see here, just before the column name for the number type, sigma notation, you can find it here. If you click on this column, you can see that the default aggregation function used was sum. So what happens is, behind the scene, it does the aggregation automatically when you drop the column into visual. The default aggregation function is sum. And if you want to change it, you can change it here itself. The average, minimum, maximum, all this, but it is not recommended the using the default aggregation thing. Anyhow, we'll discuss that later on. That is not the best practice. We'll discuss it later about that. At this moment, you just understand the moment we drop any number data type column into a visual, it gives you the total sales aggregation. It gives you the total sales sum. It does the sum on the entire column. Entire values in this column. Okay, the sales amount column. Okay. So now what I do is I just go here, the location, dim location table, and then I drop the location name along with this value and see the magic. What is happening here? Earlier we saw the moment when I dropped the sales amount alone, I got only one value. When I drop the location name, the text column along with this one, it gives me the breakdown of sales by the location name. Forget about this one. This has some blank value. We'll discuss later. So Bangalore, Chennai, all the city, you can see it here. You can see that the breakdown of the sales. So with this, we can understand in Bangalore, how much total sales we made out of this overall total. Out of 4,56,000, we made 5,532. It gives me the breakdown. Did I write any program or logic or any measure? Did I create it? No, nothing. That is the beauty of the Power BI tool. It gives you the breakdown. All you need to just drop the number column, number data type column, and along with that, if you drop any text column, any categorical column, I will give you the breakdown of that value. How it is happening? What is happening here? This location name is coming from which table? The dimension location table. The sales amount comes from the sales fact table, right? So this one comes from the sales fact table. So the location dimension is filtering this table. That is what is happening. Location dimension table filtering your sales fact table. So that is what, so when you create the relationship here, right? So one-to-many relationship. So what it says is location dimension table now can filter your sales fact table. Okay, if I remove the relationship, what is going to happen? And if I switch to my report view, see here, this total sales got repeated across the rows. The slicing and dicing is not happening here. It's showing the same amount of all the locations. Sorry, total value. It shows the total value for all the locations. The reason is the location dimension is not filtering the sales fact table. It is not displaying the values appropriately, right? That is what we can see it here. That is because we remove the relationship. When it comes to Power BI, you need to create the relationship directly. But in other tools like Tableau and ClickSense, you don't have to create it. It takes care behind the scene. But here we need to create it explicitly. But the beauty here is the moment you load the data here and when you come back and when you switch over to model view, you can see that the relationship get created automatically. That is because it checks behind the scene. Are there any common columns existing between these two tables? And it blindly it creates the relationship. In this, we don't have location name is not available here. Only column location key is available here also. The naming convention also same. Supposing here you have used the location key, whereas here you have used location ID, it will not create the relationship. Since it is always better you go and check whether the relationship got created between the tables correctly or not. Okay. And again, the naming convention should be, followed correctly. Otherwise, it can cause some problem. So, okay, the next step is if I go here, you can see that the filtering is happening correctly. First of all, what is filtering? Filtering. If you see any YouTube videos, also others videos, they keep on talking about filtering. So what do you mean by filtering? This is let's assume that these are the two different tables. Okay, so these two tables are, this is your fact table, this is your dimension table. I just say this is my customer dimension table. Sorry, this is my, 1 second, country dimension. This is my country dimension. This is a sales fact table, something like that. Okay. So here, here we need to create a report wherein it should show the sales by country. Okay, it should show the breakdown of sales by country. Country name should display it. Okay, country name should come here, and then the sales should come from this table. These two columns are available in two different tables. If I want to get the data from these two tables, these two columns, you need to create the relationship between these two tables. How do you create this? You need to create the relationship between these two tables based on the common column. Country ID is common between these two tables. Okay, once you create the relationship, what will happen is it goes to the first record in the dimension table, because it is something like we can see that is a one to many, right? So star, that is what you can see it here. When I go here, 1 second. I'm talking about this one and star. For each instance, many values are there. Okay, here the dimension. What happens is, in this case, once you create a relationship between these two columns based on the common column, it goes to the first record and the country ID, right? So US, this one will get propagated to this fact table. That means this value will be sent to this table, and then the corresponding records related to this value will get filtered automatically. Step one, it will propagate the value from your country dimension to the sales fact table. Which value it propagate? The country ID value. The second step is whatever the records that are relevant to US will get filtered automatically. And then the third step is it applies sum on the US records only, on the sales column. It applies the sum on the, let's say you have used the sum function. Aggregate, you can use all the other aggregate like average, min, max. Let's assume that sum function. It first groups all the US related data records, and then it applies sum on the sales column. And finally, it gives you the US, what are the totals? What are the total sales, right? It gives you the total sales. And then next, it goes to the second record, and it propagates the Australia data to your fact table. Okay, and it filters the records that are relevant to Australia. It kind of a grouping the records, okay? And then it applies the sum on the Australia record sales column. Similarly, it goes for the next record. So if you don't create the relationship, it will not propagate the value here. If it doesn't propagate the value, how it can do the filtering, right? In order to happen the filtering, you need to create the relationship between the tables. Now we understood the importance of doing the data model. Without data model, the slicing and dicing will not happen in Power BI. So what is the relationship? Relationship in Power BI means filtering or slicing and dicing. Okay, and the ability to slice and dice a table by another table. That is what a relationship. The location dimension table and sales fact table. If we take that, the filtering is happening. You can do the filtering only when you have the relationship between the location dimension and sales fact table. We use a term called slice and dice in business intelligence. This term is very common, slicing and dice. You can slice the data and dice a table of your sales fact table using your location dimension in our example. Okay. This is not the process flow we discussed earlier. Identify the entities. As per of conceptual data model, we identify all the entities. Entities are nothing but the tables. What are the tables are required first? And then the properties of each table, what columns needs to go in there. And then next one, the relationship. And finally, we map the attitudes to entities completely and then visualize the data. And then what we do is once we do the visualization, and if everything is meeting our requirement, what we do is we'll go and finalize and vet it with our stakeholders. Assign keys as needed. Yes, the primary key, foreign key, right? We will be assigning it. That is the other step. Next one is the star schema. What is star schema? The idea of the star schema is to keep all the numeric values in a separate table called fact tables. See, in this case, the sales is a fact table. In the case of data warehouse, we do the data model design. Even in the case of data, we do the data model design. Even in OLTP, we do the data model design. But when it comes to data warehouse, data modeling, we call that as a dimensional data modeling. As part of dimensional data modeling, there are two options are available. Okay, either you can do the dimensional data modeling with this approach, star schema. The next one is Snowflake. Either you can do the dimensional modeling, star schema dimensional data modeling, or Snowflake dimensional data modeling. You can do it. What Microsoft recommends, better you use star schema, don't use Snowflake. Okay. Now we will understand what is star schema is all about. In the case of star schema, you have a fact table. Surrounded by the fact table, you have the dimension tables. All these customer, product, date, territory, order, and reseller, all these tables are your dimension tables. The dimension tables are also called as a lookup table. The dimensional tables are also called as lookup tables. Okay, and these are your lookup table, these are fact table. The idea of this star schema is to keep all the numeric values in the fact table and put all descriptive information for these fact tables into other tables called your dimension tables. These are your dimension tables. Descriptive information about your fact. For example, you have units sold here, units sold. This is the numeric type. This is a numeric, this column will have numeric values in it. But to give the context to this value, it is also called a fact. Okay, all the numeric data type in the fact table are called your fact. So to give context, if I say something, some number, let's say if I say 801 units sold. The next question, what you will ask is, what is 801? Can you tell me what exactly 801 is all about? In that case, I can say, let's say hair dryer, Philips hair dryer product, we sold 801 in March month. If I give context, like which product you sold, right? So if you say 801, it doesn't make any sense, right? If you say what exactly the 801 is all about, for that, you need to have the product detail, right? So you need to know the product. If you have the product dimension table, which captures the description about the product key. Here you see the product key. See, basically the fact table will have the combination of key plus measures, key plus facts, The facts also called as a measures. The key plus measures or the facts, key plus facts. Just give me a second. Somebody's knocking the door. Sorry, okay. So this is the idea of this one. So you keep all the keys of your dimension tables into your fact table plus the measures. That is what your fact table. Keys from all the dimension table, product key, customer key, and territory key, line key, and reseller key. You will keep all the key column from the surrounding dimension tables. Along with that, you keep the numeric values. The numeric values are also called the facts or measures. Understood? To give context to these measures, we the descriptive informations are stored in other tables. The other tables are nothing but your dimension tables. Usually, the fact tables will be surrounded by the dimension tables that explain those facts. Okay, they explain the facts that are there in your fact table. So when we look at this data model with the fact table in the middle surrounded by dimensions, it appears like a star. Hence, it is called as a star schema. Got it? But if you see here, all the keys from the dimension tables are flowing from the dimension table down to your fact table. That is what we can see it here also. Look here, the dimension table. The location key is flowing down from your dimension table to your fact table. That is what we can see here. So we understood what is star schema. Star schema consists of the dimension tables. I just write it here. So keep, in this case, we keep all numeric values. But don't tell me all the numerical customer age. I have customer dimension. The customer age is a numeric value. No, it is not that. So all the numeric values in fact table. The business columns, okay. The business columns are like a sales, units sold, that I'm talking about. And keep all descriptive information and the surrogate key. Into other tables called dimension tables. The dimension tables will have the surrogate key. This is called the surrogate key, the customer key, product key, sales territory key, and sales order line key, and reseller key. This is a primary key. It's kind of a primary key. The surrogate is kind of a primary key. You cannot have a duplicate values here. Okay, and the dimension tables will have the description along with the surrogate key. Surrogate is nothing but your primary key column. And then the fact tables are surrounded by dimension that explain those facts that you need to remember. The dimensions are not joined to each other. If you see here, these two tables, we don't see any relationship. All the dimension tables are connected with my fact table, whereas the dimension tables, you don't see any connection. You don't have any relationship between the or amongst the dimension tables. This is what star schema is all about. The next one is the snowflake schema. What is snowflake schema? It is an extension to our star schema. This is the snowflake schema. So in this case, what happens is it adds additional dimensions, usually representing it as a hierarchy. Look here, you see here, this we can see an hierarchy here. The previous case, star schema, all the dimension tables were directly connected to the fact table. But in this case, if you see this dimension table and this dimension table, these two dimension tables were not directly connected to your fact table. Instead, these two dimension tables in turn connected with another dimension table. In this case, what happened? We have something called dealer dimension. Okay, so instead of storing the location and country data related to each dealer in a single table, they decompose this dealer dimension table into three different tables. They splitted this data and stored in the three different tables. Why? Because if you store everything in a single table, it can lead to redundancy. It can consume more space. So hence what they do is they split this table into three different tables to overcome the redundancy related issue. But in this case, what happens is if you wanted to know the location wise the revenue breakdown, so you need to have the dealer table. You need to import the dealer table and then along with the location dimension table. Okay. Otherwise, what will happen is it cannot directly talk to this table because it has to talk to this table and this table has to talk to this table. Okay, so in order to get to know the sales revenue breakdown by location, it has to navigate from location to dealer, from dealer to revenue, because the dealer only has the location ID and location ID. Whereas here you don't see the location ID in this table. You don't have the location ID. Okay, so the location ID should be there here. Location ID will be there. With that location ID, they are, but this location ID, if you wanted to see the location name or region name, the region name for each location ID is stored in this table. To get to know the region name, you need to navigate to this table via this table only. Okay, so here we are breaking down a single table. So basically we are doing this is called normalization. In the OLTP database, they use a data modeling technique called normalization. In the case of data warehouse, they use a data modeling technique called dimensional data modeling. So as for dimensional data modeling, we denormalize the data. Denormalization, we do it in data warehouse. So in that case, we go for star schema technique. Whereas in the case of Snowflake schema, we do the normalization in the dimension table itself. This is to overcome the redundancy. So we want to utilize the space or disk space efficiently. That is the one key advantage of using Snowflake schema. What is that? It uses lesser disk space because you are splitting the table and store the relevant data in different tables, right? So what happens is you can save the space. It is easier to implement a dimension, right? So that is added to your schema. But in this case, what happens is if you wanted to know the revenue breakdown by location or revenue breakdown by country, you need to navigate to additional tables. It requires joins with multiple tables. More joins you have, obviously, it will slow down your performance. That is one drawback with Snowflake schema. Hence, what we do is we denormalize these three tables were currently normalized. We need to denormalize this one. If we denormalize this, which means keep all the information in a single table, you call this a dim dealer. So that is your star schema. Now you understood the difference between star schema and Snowflake schema. Next one is the fact table. What is the fact table? The fact table, this I already discussed, right? Contains measures of a business. The items to be aggregated. Items to be aggregated, like unit cost, sales revenue, profit, units sold. These are your the numeric values. Facts. It is also measures or facts. Either they call it measures or it's all called as a facts. So the data in a fact table should be sliced and diced by the data of dimensions. The fact table has a many-to-one relationship to every dimension, or we can say one-to-many or many to one. This is your many side. In Power BI, it uses star notation to represent many. This is one side, and this is one side, and this is also one side. This is your many side. Now you understood what is star schema, snowflake schema, what is fact table, what are dimensions are all about. And within the fact table, there are different types are there. You have transactional fact table. So they use a term called granularity. So day level granularity. So every day transaction should get into my fact sales. So that if I wanted to do like for like analysis, even for the day base, for example, today's sales versus yesterday's sales, I should be able to do it. The lower the granularity, when you store the data in your table, you can perform slicing and dicing. You will have more flexibility, right? So you can give more detailed information. The lower the granularity, which means the day level in this case. So you can perform slicing and dicing at a very granular level. Next one is the periodic snapshot fact table, accumulating a snapshot fact table. What they do is they'll keep accumulate the facts. For example, 2 weeks data, they will, monthly. So what they do is once in a week, they will keep add the data and weekly load. Every week, they load the data in a fact table. They'll be keep accumulating it here. Periodic snapshot is also same thing. But here the accumulating and periodic this is kind of a weekly thing. But here it's kind of a aggregation. They do some kind of aggregation, accumulating snapshot. In this case, every week they aggregate the data and then they store it here, aggregated information. Here, every once in a week they load the data, something like that. And the factless fact table is kind of a bridge table. If you have many-to-many relationship, that kind of situation, we will use the factless fact table, which is nothing but the bridge table. So in this case, as the name suggests, you will not have the fact in the table. What is fact? The numeric values. Only the key columns will be there. The measures will not be there. So these are the fact tables. These are not, you will not find these terms in Power BI desktop. While working, you will not find these terms and all. But this is data warehouse concept. You should be knowing it. Okay. This is a classic example for factless fact table. So this is what your factless fact table. So you have salesperson and region table. And in this table, see, if you take this table and you wanted to slice this table, or I wanted to use my region table to slice this table, it is not possible because in both the tables, we don't have the common key column. Here you can see the salesperson key, here you can see the territory key. That's all. Nothing is common between these two. And also each salesperson can be assigned to more than one region, and each region can have multiple salesperson. So there is a many-to-many relationship here. Okay. So in this case, what we have to do is to address the many-to-many relationship, we need to bring in a bridge table. Bridge table or link table. It is also called a link table or bridge table. That's why I said it's a factless fact table. It's a fact. The fact table will have facts in it. As the name says, factless fact table. This means you will not have the numeric values in this kind of. There are fact table, you will not have the numeric values. This is called factless fact table because of the many-to-many relationship. Okay. Because why many-to-many relationship is not preferred? Because if you wanted to filter the value from one table to another table, you need to have one-to-many relationship. But if you see here, these two tables, you have each salesperson have assigned to multiple region, and each region is assigned to multiple salesperson. Many-to-many relationship. So either this column should have unique values or this column should have unique values. Both the columns have duplicate values. Hence, you cannot do many-to-many relationship. Okay, you cannot. So with the many-to-many, you cannot do filtering. Hence, it requires a bridge table. This is very common practice as part of the data model design. If you are a business analyst, you should be knowing it. Okay, and this is how you need to design it. So the interview, they'll ask you, how did you implement? What kind of workaround you do it when it comes to many-to-many relationship, or how did you implement the many-to-many relationship? So we simply introduce a bridge table, okay, and to overcome the many-to-many issues. So with the help of many-to-many, sorry, with the help of the bridge table, we make sure that both the tables, key columns, we store it in a bridge table. With the help of the bridge table, we can do the filtering of both the tables. Correct. So this is what factless factor. So it means here factless means this fact table will doesn't have any facts in it, numeric value in it. Hence it is called factless fact table. Next, we will jump in and understand what are the different types of relationship that are available. And so this is not specific to Power BI. This is specific to data modeling. So for the data architects, they are the one, usually they do the data model design, whether it is a OLTP or dimensional data model design. So the data architect, they are the one responsible for doing this one. But when it comes to Power BI, yes, you should, as a Power Report developer or designer, you should also be knowing the type of the relationship. What is type of relationship was all about? This is not specific to Power BI. That is what I'm trying to say. Next one is the active and inactive relationship. The rest we will see if I can cover it today. Otherwise, we'll continue tomorrow. Now we'll jump in and understand what is a relationship is all about. First of all, it is nothing but filtering. I explained to you what is filtering. If you don't create the relationship between the tables, you cannot do slicing and dicing. It is as simple as that. And what is a cardinality? Cardinality is nothing but the type of relationship, the relationship between the tables. There are 4 different types of relations. One is one-to-many, one-to-one, one-to-many, many-to-one, many-to-many relationship. So one-to-one, what is an example for one-to-one relationship? So this is the one, the other number, other card, and citizen. Each citizen should have a unique Aadhaar number. Once you generate an Aadhaar number and you assign it to a citizen, this number should not be reused. Okay. And each citizen should have only one Aadhaar number, and Aadhaar number should be assigned to only one person. It should not be assigned to, the same number should not be assigned to more than one person. This kind of one-to-one, in US, they call it the SSN number, Social Security number. Okay, next one is one-to-many. You have 2 tables. Let's say you have 2 tables here, one-to-many. Here, let us say you have manufacturer. A single manufacturer produces multiple products, more than one products, P1, P2, multiple products. This is an example for one-to-many. The typical example is the car. A single car manufacturer produces multiple models of a car. One-to-many. So next one is many-to-one. So many-to-one is something like what is a many-to-one? So this one, the single product, right? So each order, right? Each order will have multiple products in it. Okay. The other example is employees. Let's say you have employee table. Multiple employees are working on a single project. So multiple products can appear on a single order. So this is many side, one side. The opposite of one-to-many is many-to-one. You can, even if you put the table in the opposite thing, right, you will get the many-to-one. And finally, the many-to-many relationship. What is many-to-many relationship? Multiple records in a table are associated with multiple records in other table or called your many-to-many relationship. In the many-to-many relationship, you cannot implement it directly. It requires some kind of treatment. Okay, so to implement the many-to-many relationship, you need to introduce a bridge table. Okay, so in between the 2 tables, you need to have a bridge table here. By introducing a bridge table, when we can overcome the many-to-many relationship related issues. Okay. So what is the example for many-to-many relationship? Like I said earlier, the salesperson and the region. Single salesperson assigned to more than one region, and at the same time, each region has multiple salesperson. Let's say you are a salesperson A. Person A got assigned to region 1 and region 2, the same person. And similarly, each region have more than one salesperson, A, B, right? So this guy have more than one, here, and even this one has multiple employees. So many to many relationship. So it requires some kind of, because both the table, these columns, the key columns are duplicated. At least any one of the tables should have only one non-duplicate values. Only then you can do the filtering. Since you have the duplicate values and is available on the key columns in both the tables, we cannot do the filtering correctly. Okay, that is the reason why we introduce a bridge table. All right, so everything is good. The next one is the lookup tables and data tables. Lookup tables are nothing but your dimension tables. Some people, they interchangeably use the term lookup instead of dimension tables. Hence, don't get confused. Both of them are same. And the fact tables are sometimes they call it data tables. It depends on the customer, depends on the project. They use different terms, but these are the common term that you should be aware of it. Okay, the alternative term. So fact table carries all the transactions. The lookup tables carries all the filtering information. In a one-liner, we can define what is a fact table dimensionable this way. The next one is a very interesting one, the active and inactive relationship. So what is active and inactive? Just give me a second. Let me just see this one.